Hello everyone, welcome to my YouTube video. This is Dr. Song. We were so much concentrating on until the last session about the all descriptive statistics. We are finally in the week 6. So we will cover the errors in the inferential statistics and the selecting tests. In this week, we will see the very intensely about the inferential statistics. The basis of the statistics is a descriptive statistics. So that is a very important part, of course, and then we took a lot of time to cover that. But inferential statistics is basically the core part of the research. So when you have your data, collected data, and then you clean your data, and then the descriptive statistics can be used to clean up your data. And then you are ready now to proceed with the inferential statistics. So this is the core part of your research, and then you can obtain your research of your research, and then after analysis, and then you can decide that you reject your hypothesis or you accept your null hypothesis. So this is really the last part of the research can be. So let's just study about the inferential statistics. My course, as I already told you, I was how can I say that inspired by those classes. They are the statistic courses in the University of Ottawa, and then these are the professors' name. Before going to the our part of the inferential statistic, which remains that is the in the descriptive statistic part, that is about the error. So you heard about this error is a very important concept in the statistics. So when you obtain the one number, the value, and that is not exactly the absolute value because we always deal with the samples. So we don't know about exactly the population already we have to guess with our sample. So for this reason, the error, how you put the error range, the range of the error, this is very important. So I will show you in this session how you can decide the error range with the different methods. The first thing about the error, you can think about the concept. So when you obtain the one value of the A, B, C, D, E, for instance, and then they have the kind of average of the mean. Mean value is 35, sorry, so 70, 95 or 50, 25. Yeah, that is 75. 75, and then this is under 50, and etc. In fact, these values, it cannot be the absolute. You have to think always there are the errors about this value, and then the mean value here. So how you can draw the mean value and then the errors? So we call that is error bars. That is a graphical representation of the variability of the data, and then they are drawn by this way the bars. So the first one, the error bars, there are three kinds of the calculation possible: standard deviation, standard error, and the confidence intervals. And in the confidence intervals, you have also the two different ways to obtain the confidence intervals. So I will show you about that. And then the very first one, standard deviation, that is just simply you will deal with the standard deviation for your mean value. So the mean value is 73.50. And then let's assume the standard deviation is in this amount. So that is let's see that we can calculate that. So 73.5, that is a mean, and then you can add the 84 and the 6, that is the first 34%, and then you can subtract, that is like a point, and then 1, and then 1. So 11.1, that is the standard deviation. So first standard deviation 1, you will calculate that from your average value plus 11.1, and then that becomes the 84.6. So this is the way how you can add your 34% range of your data. That is a standard one range. So here you can put the top is 8460, and then in the mean is a 7350, and then you the subtract again 11.1, that becomes 62.0, 62.4. So that is in the bottom. So you can put that is that is like error bars, the range. So the top is the 84.6, and the bottom it will be the 62.40. So this is their range. So this means that between those range, yeah. So the between the those range, 34% here, it's like you can accept that as that is like a mean value. So mean value is 73.50, but if somebody has the 84.6, somebody has the 64.4, you will consider them they are not is a big difference. So they are like the error bars range. So that is one thing you can obtain by that. And then another way of the error bar, you can divide the standard deviation is by the root n. So the n means that is a total number. So total participants number, and then you put the root, and then that you can divide your standard deviation. So your standard deviation is 11.10, and then there were how many people? There were 8 people, and then you put the root, and then you can obtain. So what you can do now after with the standard error, your mean value is here, and then you can add the 3.92. You can subtract the 3.92. So that becomes your error bar now. So you can see that here is you can do the standard deviation itself, or you can do the standard deviation divided by the root n. So now we will talk about the confidence interval. In the confidence interval, we have the different ways. So you can use the in fact here you can see that confidence interval is with the standard deviation or arrays, but you will multiply by 1.96. 1.96 means the z-score of the 95%. So in general we use the confidence interval with the 95%. So you can use the 1.96. But if we want the 99% of the confidence interval, you can use also. In this case, 1.96 becomes 2.58. So you have to multiply plus minus 2.85, then becomes 99%. But in general, in statistics, when you will proceed with your analysis, normally we use the z-score 95%, so 1.96 you have to remember. Okay, so you can see the standard error here, how that is obtained. Standard error is that you can have the standard deviation and then divide by the sample and then the root. So that is the standard error. Okay, so that means that when you have the more sample size, that will be the 100 or 200, etc. Of course, your standard error will diminish, will decrease. So that is a good sign because you will be more close to the real value. So that is the concept about the standard error. And then this is the one way how you can obtain the confidence intervals. So you can see the example here. The upper will be 73.5, the error bar, and then your standard deviation, and then multiply by the z-score 95%, 1.96, and the lower will be 73.5, and then that is a minus, yeah, this is minus, so 11.10, so that becomes the 53.44. So this is the error bar in this case about the confidence intervals by the by the way of the confidence intervals. So this means that it's much larger. Yeah, it's much larger. Even though you have the mean here, and then this top and the bottom, in fact, those things are the error area. So if somebody has a 97.06 and the bottom is a 53.44, that is considering the 95% confidence interval. That is the like a same value. You have to consider that they are not is a high and a low, but still they have a range of the confidence interval. So even though somebody has this number or this number, you will consider that is in the area of the error bar. Okay. And then another way I told you the confidence interval you can obtain by this way. So it means that it's a m plus minus standard deviation and then multiply by 1.96. That is one thing, and then the other way is another way. So you can do the Z score like on 1.96, that is 95%, and then you will do that with the standard error. So here you can see this is with the standard deviation. That is the first way. And then another way is a second way is with the not the standard deviation, a standard error. You can put the standard error and multiply by the Z-score 95%. That is also confidence interval, and we call that margin of error. So that also you can obtain by this way. So you can see here that is the calculation you can do. So the like your mean plus and the minus Z-score, and then you will multiply by the standard error. That is also possible. Anyway, the result is the same. Even though you do the standard deviation, standard error is almost same. Standard error just is like a standard deviation and then divided by the root n. Okay, so that is almost same. So the 90% is a 1.96 instead of the Z-score here 1.96. That is not the 95%, it's 90%. And then this is the 95%. So normally in the standard way you will use this 1.96. So when you see the like this kind of graph and with the error bar, yeah. So you have to see that they are like crossing in this part and also like here this part. So you can consider that this person and this person is not a big difference, and then this person and this person is not a big difference. However, this person and then this person, yeah, they have big difference because they don't cross. They don't have the overlap. They don't have the overlap between the CMN 3102B and then CMN 3102C. They don't have the big. They have the big differences. So between them, you can say that there's a significant difference. And then also in this graph, you can see that all of them, they have the big difference because there is no overlap with this. And then also with this no overlap and then this also. So we can say that all this difference between the 3102A, B, C, they have the big difference of their average of the score or three things. So here, the question, which of the statement below is the most true based on this chart? So we can say that the women and the men, they have the big difference. Women receive the more like than men. It's like social media like. We can confidently say that women receive the more like than men because there is no overlap between these two error bars. So this means that it's a big difference between the women and men about the like, and you can confidently say that women receive the more like than men because if they are overlapped, and then you cannot say this, but in this case you can. Okay, so this is the just before starting the inferential statistics. We covered the rest part of descriptive statistics about the error bars. Thank you so much for today, and then I will see you next time.